Divide the polynomials and find all zeros. This exercise is a little different from the last one you saw. In addition to dividing these two polynomials, you are also asked to find the zeros. The first direction is to divide the polynomials, so let's concentrate on that. The first thing we will do is divide the first term of the dividend by the first term of the divisor. I'm going to do that off to the right. So 6x cubed is the first term of the dividend. X is the first term of the divisor. That gives you 6x squared. And recall, you have to line that up with the correct exponent of the dividend. Since this is part of our quotient, I'm going to line that up on top over the other x squareds. 6x squared. Then we distribute this 6x squared to each term here, and when you do that, you get 6x cubed minus 12x squared. We will subtract these two things from the current dividend to create a new dividend. 6x cubed minus 6x cubed reduces away to 0. Negative 19x squared subtracting a negative 12x squared. Subtracting a negative is like adding, so negative 19x squared plus 12x squared leaves you with a negative 7x squared. Bring down the plus 16x, and when I do these exercises I always bring everything down so you can see the entire new dividend all at once. So with the new dividend here, we divide the first term of the dividend, it's negative 7x squared, by the first term of the divisor. Notice the first term of the divisor does not change. So when we do this, we're left with negative 7x. And again, I'm going to line that up in the top, that's part of our quotient, minus 7x. And then distribute that to each term in the divisor. And when you do that, you get negative 7x squared plus 14x. We subtract that away, and you get negative 7x squared minus 7x squared reduces away to 0, which is nice, that's what we're looking for. 16x's minus 14x's. So 16 take away 14 will leave you with 2x's, and we bring down this minus 4. Now our new dividend is 2x minus 4 down here at the bottom. The first term of that is 2x. Divide it by x. When you do that, you get 2. That is a constant, or it has an x to the 0 power hanging around out back. So we come all the way up here and we line this up with the constants. And again, we distribute this 2 to the x and this 2 to this negative 2. And when that happens, you get 2x minus 4. We subtract these things. 2x minus 2x reduces away to 0. Negative 4 minus negative 4 reduces away to 0. So we have a remainder 0. A quotient up here of 6x squared minus 7x plus 2. Here is all of the pertinent information from the previous slide, and something really nice happened. When we divided our dividend by our divisor, we got a remainder of 0. What that means is we have effectively factored our dividend. You might look at that thing and say to yourself, well, that doesn't look factorable. Whenever you get a remainder 0, that's what essentially happens. If we take a look, it's 6x cubed minus 19x squared plus 16x minus 4. That essentially got factored over into these two terms, x minus 2 and 6x squared minus 7x plus 2. So our dividend was factored into our divisor times the quotient. And that's really nice because when we're trying to find zeros, having something hard like this and being able to factor it into something easier to solve will make finding zeros much, much easier. So we can take this divisor, x minus 2, and set it equal to 0, and that tells us x equals 2. So there's 1 0. And just for some added bonus, this has multiplicity 1. Then we can take a look at this second part, our quotient, this part, and we know that that is 6x squared minus 7x plus 2. And that factors nicely into 2x minus 1 and 3x minus 2. And when we set each of these factors equal to 0 and solve for x, we get that x equals 1/2 and x equals 2/3. So these are zeros, and here is another 0. All of them have multiplicity 1. Let's take a look at the graph of this on the next slide. So as a little added bonus here, we're taking a look at the graph of this polynomial which you were dividing to find the zeros. We successfully found the zeros in the last slide to be 1/2, 2/3, and 2. With some extra effort, you can find the information, the degree of 3, the leading coefficient of 6, and the y-intercept of -4. With this information, the degree is odd and the leading coefficient is positive. This tells you that the graph will be rising to the right and falling to the left. The y-intercept is -4, and I've already plotted that here. I've already plotted the zeros at 1/2, 2/3, and 2, and I've already drawn what a sketch of this graph might look like. As you can tell, it follows everything that we know it needs to follow. It rises to the right, it falls left, it crosses the y-axis here, it crosses the x-axis at the 3 zeros we found, each with multiplicity 1. So this graph will cross the x-axis at each 0, and it does. So there's the graph of a sketch of a graph of 6x cubed minus 19x squared plus 16x minus 4.